All right, we should be just about ready to get started for the day. Today is March 24th, the first day of distance learning. Everyone's just jumping into the A1 class right now. So here we go. We're going to record a day's worth of lessons online. It's going to be great. So here we go. Let's do it. Everybody should be able to see this now. Hello, students. Hello, A1, Algebra 2. How exciting. Everybody's here. Everybody's ready to do some learning. Look at this. Everybody coming on in. Ready to do some learning. Hello, hello. Going to ask that you guys make sure that you turn your webcams off and your microphones muted. Of course, you can speak up now if you want to say hello, but this is how it's going to be. Now, check this out. Hold on. Hold on. But wait. Wait. You think this is all there is to it? You think it's just going to be a voice recording? Oh, no. Oh, no. Hold on one second. Oh yeah, oh yeah, we are ready to go in here. We are ready to go with some Algebra 2, baby. So excited to see. It's so great to actually see everybody back from this crazy week of isolation. But Al, thank you, Steph. Appreciate that. Appreciate that. I'm excited. A lot of work that went into this. It's definitely something that I never thought that I would have to do in my career. I'm sure you never thought you'd have to do distance learning or anything like that. But yeah, we're going to see how it goes. We're going to see how it goes. So all I ask is that you please be patient with all of your teachers. I definitely consider myself to be a little more on the tech-savvy side, but even I have never done something like this before, and so this is going to be an entirely new experience for me. And so especially for some other teachers that are less familiar with technology, I just ask you to be patient and be considerate for them, because we're all trying to make this work to the best of our ability. So thank you, Michael. I appreciate that. Saying this is epic. I wish I could actually have the chat up on the screen. I can't do that because it doesn't support via Google Meet. But I did look into it, though. I was like, oh, I wonder if I could have the chat stream to the window there, but unfortunately not the case. Hello, Isabel. Everybody's jumping on in. We got Alec here, Katie, Michael, both Michaels. Stephanie's here. Fantastic. Ben Margolis was the first one, actually. That's great. This is being recorded, by the way, just something you should keep in mind, and it is being kept track of. So, you know, be mindful of that as we're going about our class time here. Again, asking that you make sure you mute your microphone, make sure you turn your webcam off. You can feel free to unmute your microphone, and if you have a question, feel free to ask and interrupt me, or type it in the chat, either way, and I'll be sure to answer. But make sure those two things are done. Also, make sure you do the attendance on Google Classroom. So you should have the attendance sheet there. You should be able to go ahead and fill it out. And that should be all there is to it. Tried to make it as easy and as streamlined for you as possible. This is going to be the same link every time that we use to get into class. So it's not going to be a different one every day. We're going to be using the same one every day. Luke, jumping on in. Hello, Luke. Good to see you again. It's good to see everybody and be connected with everybody again, you know, isn't it? After this strange, weird week of uncertainty, it's great to now just be all back together. I definitely missed a lot of my classes and a lot of my students for sure. So yeah, webcam's off, mic's muted, which is great. Trevor says he'll be on. No, wait. Trevor? Oh, right. Now it's going to be a party. That's great. I'm so happy to hear that. So happy to hear that. So hopefully everybody also has that little worksheet loaded up too. That's pretty much what we're going to do today in this little 30-minute block starting in 1 minute from now, is pretty much just go over those problems, make sure that we're all on the same page with what we did prior to the week break, and then go from there. Kaden jumped in. Aiden Mata is here. Alexis is here. Bailey's here. Everybody's jumping on in for some Algebra 2. Hello. Welcome to day 1 of distance learning. I am going to ask that, again, people just jumping in, if you haven't done so already, please make sure you turn your microphones off, mute to make sure they're muted. You can feel free to speak up if you have a question during any of this. Like, don't be shy. Type it in the chat or speak up if you have a question. And make sure that your webcams are off as well, just because that can get distracting. But again, make sure your microphones are muted. Make sure your webcams are off. We'll get started in exactly 2 minutes. We'll give people 2 minutes to jump on in. Kaylani jumping on in, joining. which is fantastic. Again, make sure webcams are off, make sure microphones are off. Everybody should be able to see my screen. We're going to be doing some great radical functions review. Everybody should also have the worksheet open, hopefully in another tab. We're pretty much just going to be running through those problems today, making sure nobody has any questions on the materials that we've covered before break. Again, if you haven't done so already, please make sure you sign in via the attendance sheet on Google Classroom. So make sure you sign with attendance on Google Classroom. I know my webcam's a little choppy, at least the footage is. Looks like I have like some motion blur going on, which is kind of cool. Which is kind of a shame because on my preview window it's nice and smooth, but I know projected for you it looks a little choppy. But that shouldn't really be a problem. The document camera is actually pretty fluid, so the fact that the document camera is working out okay should be good for us. So I'm happy about that. Again, we'll just take about 1 more minute. Julia coming in. Katie is here. Both Isabels. Edwin jumped on in. Very nice. It's so great to see everybody all logging in. Again, make sure you take the form on Google Classroom. Just fill that out. Take attendance really fast. It should take 2 seconds. It's right at the top of the classwork page on our classroom, just to make sure you fill out that Google form to just check in that you are, in fact, here for virtual learning. Again, I asked that Adelso is here. Fantastic. Again, I asked that you mute your microphone, turn your webcam off if you haven't done so already. I see everybody's muted their microphone so far. Hopefully everybody's webcam's off too. I trust that it is. So we're going to get started, I guess, in just a little bit. Fill out the attendance sheet. But yeah, this is pretty much how it's going to be for the next 2 weeks. You know that the schedule alternates days between blue days and white days. The schedule is here for your convenience. Just a couple of reminders that you see over on the left side, the classroom code. And as long as everybody's here and ready to go, Ryan just jumped on in. Fantastic. Good to see you. Olivia, welcome. Welcome. Happy to have you on board. As long as everybody's ready to go, I guess we're just going to get started with our first day of Sydney Kell jumped in. Our first day, and Maddie's here. Our first day of CHS virtual learning. Here we go. Or distance learning, I guess I should say. CHS distance learning. But distance learning is going to take on this virtual form today. Again, one final reminder before we get started officially. Make sure you take attendance on Classroom. There's a little Google form to fill out just to check in that you are, in fact, here. Make sure that you have that little assignment opened in another tab. I posted on Classroom yesterday, that little distance learning assignment day 1. Hopefully you at least attempted that on your own. I think it was important to try that out just to make sure you understood what was going on prior to this, because we're going to go over those questions right now. Again, make sure webcams are off, microphones are off, but please feel free to speak up if you do have any questions during this class. All right, so without further ado, oh, Luke just said it right here. What is the time period I have to do the attendance? That's a great question. I have to take it, well, really I'm going to be submitting it at the end of this class. So that's really what I'm going to do. But looking at the timestamps, I'm really going to look at, because it is timestamped when you do check in, I'm going to be looking at people who have signed in before probably like 10 past. So about 10:10, I'd say, is your deadline to sign in to be on time. I think that's a pretty fair idea, because that's not fair to people who are here and would miss out otherwise. But all right, let's get started so we don't waste any more time. We do only have limited time together every day, only a half hour, but it is exciting to have everybody on board again. So again, what I would really like to accomplish today is I'd really like to talk about these graphing problems and the solving problems, which were essentially what we did prior to our impromptu, or not, I guess not impromptu, but unannounced, unforeseen 1 week vacation. So I want to do definitely one example of graphing square root, one example of graphing cube root, and then we'll jump into some of the equations. And if we have time, we can do more than that, but I'd like to at least do those 4 different types of problems. On that distance learning assignment that I linked for you, I am going to get started just with problem number 1, which is just a basic square root graph. I can show you how to do that, and then we'll go from there. All right, so getting started here, problem number 1. Problem number 1 looks like this. We had -2 times the square root of x plus 5 and then plus 3. And I asked you to graph that function, so sketch a graph of that. If you recall, a square root graph is really all about the goals. So when graphing these square root functions, we do want to create a table of values. Notice there's no GCF or anything that we need to take care of inside that square root. So I have my values for x on the left, my values for the function on the right. The very first square root value that I'd like to take here is the square root of 0, because 0 is a nice, easy, perfect square. So what value for x is going to allow me to take the square root of 0? It's going to be -5. Because if you notice, -5 plus 5 would make 0. And that's a nice, easy calculation that I'm comfortable doing, right? It's not this crazy, difficult thing to perform. It doesn't result in a decimal. It's just -5 plus 5 would be 0. The square root of 0 is 0 times -2 is still 0 plus 3 is 3. So your starting point of this square root graph would be -5, 3. So that's good. After that, we'd be looking to take the square root of 1. The value that's going to give me the square root of 1 is, let's see, it looks like -4. Because -4 plus 5 would be 1. The square root of 1 is 1 times -2 is -2 plus 3 is 1. Does everybody see how that works out, I hope? Moving on from there, we're looking to take the square root of 4. What value is going to allow me to get 4? It's -1 because -1 plus 5 is 4. The square root of 4 is 2 times -2 is -4 plus 3 is -1. And last but most certainly not least, we're looking to take the square root of 9. The square root of 9 comes from when we plug in 4 because 4 plus 5 makes 9. The square root of 9 is 3 times -2 is -6 plus 3 is -3. And so going on to my coordinate plane, I would take a look at this. Let's see, we're going to start at -5, 3. So let's make sure that we have enough room on our coordinate plane to do that. Here's my -1, 2, 3, 4, 5, 1, 2, 3. I'm just going to continue plotting the points of -4, 1, -1, -1, 4, -3. Do you see how it makes that nice smooth graph that we're expecting? Just like that. And that would be your graph of the square root of -2 times the square root of x plus 5 plus 3. So that's really how it gets done. Hopefully that's a nice little refresher of what we've been doing kind of all along. But that's the idea. Again, if anybody has any questions, just feel free to chime in the chat, or feel free to unmute your microphone and interrupt me. That's totally fine. Yeah, that's totally fine. That's totally fine. Wait a minute. Okay, very good. Sorry, I just had to check for a minute. Okay, we're still good. All right, very good. So nobody has a question about that, which is fantastic. Again, if you haven't done so already, just getting on that deadline of the attendance form, so make sure you fill that out. Okay, so everybody can hear me and everybody can see my camera, which is good. All right, moving on from there, the things that we'd be asked to find from here, we'd be asked to find stuff about the transformations, as well as the domain and range. So the transformations of this function is pretty much just asking you from the basic function of the square root of x, which the square root of x just starts here and kind of goes up like this. It starts at the origin. Where is this function? How is this function different from the regular old square root of x? So I would say, well, horizontally, it moves 5 units to the left. So I could say it's left 5 units. At least the starting point did, right? Up 3 units, so up 3 units. I'm also going to say that this function has a stretch of 2 because that's that number right out in front. And the fact that it's negative would also imply, this is going to be hard to not have my sheet shift around a lot while I'm doing this. The fact that it's a negative stretch would also imply that it reflected over the x-axis. Okay? Your domain, again, is the space that the function occupies from left to right. So I'd look here, the furthest left the function goes is -5. It goes to the right forever. So your domain is bracket -5 because it includes -5, comma, infinity. Your range is -infinity to 3 because that deals with the vertical distance. How far down does it go? It goes down forever. How far up does it go? It only goes up to 3. So very cool. Again, if you have any questions, feel free to chime in and interrupt via just unmuting your mic and saying something, or feel free to type it in the chat. But that's exactly what we talked about so far, so hopefully we're A-okay with that. Oh, we got someone? What do we got?
So a quick question. For the transformations, isn't it usually just like the horizontal shift and like vertical shift?
So Luke asked, for the transformations, isn't it usually the horizontal shift and vertical shift? The other thing we want to say with the transformations is the stretch. So we want to specify horizontal shift, vertical shift, stretch. And then this little thing that says reflected over the x-axis just means it flips upside down.
Okay,
So
and does it have to be like written out like that, where it's like left 5 units and then up, or do you just write it out like five, five, whatever?
good question. So you could also write, if you wanted to, horizontal shift of 5 units or -5, vertical shift of +3, stretch of 2. That's totally fine as well, as long as you
All
can
right, thank
communicate
you.
to me that.
Okay.
Good question. Thank you. Any other questions? I saw something in the chat. Oh, so the transformation part, Stephanie asked the same thing. Hopefully that makes sense now, yes? Awesome. All right, let's go ahead and graph a cube root, and then we'll move into our solving equations. So, very good. So a cube root function, going back to that distance learning assignment, was just number 2 on there, which was the cube root of 2x minus 1 minus 4. And we're trying to go ahead and sketch a graph of that. Much like the square root function, the cube root function is going to involve establishing those goals and trying to create numbers, or trying to come up with numbers that allow us to take nice perfect cubes. But unlike the square root, we don't want to rely on those perfect squares of 0, 1, 4, 9. I'd much rather go with the perfect cubes, because that's what's going to work nice in this calculation. So if you remember, the cube root kind of has a center point and then it goes out in both directions. So I'd start with something like the cube root of 0 right in the middle. So what number, if I plug it in, is going to allow me to take the cube root of 0? That, in this case, is going to be 1/2. Now, if again, this is what we talked about in class. If you're thinking to yourself, how am I supposed to know that that value is 1/2? I can't really see that off the top of my head. No worries. We can go ahead and create a little equation. And you could say, well, when is 2x minus 1 equal to 0? Because that's what you want it to be. You want it to be equal to 0, correct? So that would happen if we add 1 to both sides. I get 2x is equal to 1, divide by 2, and you get x equals 1/2. Okay, so you could always fall back on that little equation strategy to help you out. That's not something you have to do. If you can see it in your head, that's fantastic and wonderful. But if you can't see it in your head, that's a great fallback option. All right, so now just extending in the positive direction, the next perfect cube we want to shoot for is the cube root of 1, because that's a nice easy number. The value that actually allows us to do that is 1 itself, because if you notice, 2 times 1 is 1, minus 1 is, or sorry, 2 times 1 is 2, minus 1 is 1. The cube root of 1 is itself. Minus 4 is -3. And I didn't plug in the 1/2, by the way. This is going to be -4. Very good. After that, we look to plug in the cube root of 8. What value is going to give us the cube root of 8? Again, that's another question that you might not be able to see right off the top of your head. So we can just say, well, when is 2x minus 1 equal to 8? We add 1 to both sides. You can get that 2x is equal to 9. Divide by 2. You get x is 9/2. So that's the value you should use, 9/2, or 4.5 if you choose to represent it as 4.5. And if you go ahead and plug that value in, notice, you know that when you plug in that value of 9/2, that this is going to come out to be 8. Because that's why you chose it in the first place. You chose that value of 9/2 or 4.5 because you know that value is going to come out to be 8. The cube root of 8 is 2, minus 4 is -2. Hopefully we're still good. Fantastic. So now we got the cube root of -1. Again, just interrupt if you have a question. Looking again for what value is going to give us -1. I think that's just 0, because 2 times 0 is 0. Minus 1 is -1. That satisfies my goal. The cube root of -1 is just -1. Minus 4 is -5. And then last but not least, we're looking for the cube root of -8. What value allows us to do that? Again, just use a little equation. When does 2x minus 1 give us -8? Add 1 to both sides. When does 2x equal -7? We get -7/2, or -3.5 if you prefer. Once again, you know that if you plug in something like -7/2, this part is going to be -8. That's why you picked that value in the first place. You could work it out if you wanted to. Like, you can notice the times 2 and dividing by 2 will cancel out. And you'll get -7 minus 1, which is -8. But again, you know that that's going to occur because that's why you chose that number. The cube root of -8 is -2, minus 4 is -6. And so now, going ahead to sketch a graph. Let's see, we have to make this one a little wider. So Notice how I drew my graph somewhat off-center because I see all these y values are negative anyway, so there's no sense in wasting a lot of space. We have our starting point at 1/2, comma, -4. We have our point at 1, comma, 3, or -3, right there. We have our next point in the positive direction at 4.5, 1, 2, 3, 4.5, comma, -2. Going in the negative direction, we have a point at 0, comma, -5. We have a point at -3.5, 1, 2, 3.5, comma, -6, which is right about there. And so then you just connect them together. And lo and behold, a nice, fantastic looking cube root graph. Cool. Again, any questions, just feel free to interrupt. But just like before, we have to figure out our domain, range, and transformations. So let's start with the transformations. Just like with the square root stuff, in order to find the transformations of the cube root stuff, it's good to look at your starting point. So if you notice with the square root function, I looked at that starting point. That tells me my transformations right away. The same thing is true about the cube root function. If I look at my starting point, that's going to give away my horizontal shift and vertical shift. So you can say that your transformations is that you went right 1/2 a unit, or 1/2 units. You went down 4 units. And this one has a stretch just of 1. It doesn't really have any special stretch, so you don't have to necessarily indicate the stretch if it's the same as the parent function. You can if you want. It's not wrong to say it has a stretch of 1, but since it's the same as the parent function, it's not necessarily necessary, if that makes sense. And then the domain and range of a cube root function, everybody should know this. The domain and range of a cube root function, always 100% of the time, -infinity to infinity, because it's always going to extend left and right forever, and always going to extend up and down forever. Excellent. Any other questions or concerns about that while we transition to equations? Okay, I take it your silence means that you are not only fully engaged, but also fully comprehending the material. Fantastic. All right, so moving on to solving equations. Let's do one that involves just kind of applying a power to both sides, not really any fancy math, and then one that involves a little bit of distributing. Remember, when we solve equations now involving square roots and cube roots, it is necessary for us to check for extraneous solutions, because it is possible to get solutions that show up through perfectly legitimate algebra, but then when you actually go back and check them, they don't work out so nicely. So starting with a problem like this, let's see what we can do. We have, this is number 4 actually on the sheet that I gave you. We have the cube root of 3x plus 4 is equal to the cube root of 9x minus 38. And let's see if we can go ahead and solve that equation. Since we see a cube root on both sides, that's a lot of ugliness going on there. I don't want that cube root to be there. I'd like to get to that x, which is embedded under the cube root. So what I'm going to do is first raise both sides to that 3rd power. Notice the cube root and cube will cancel out. You'll be left with 3x plus 4 on that left side is equal to, again, same deal, cube root and cube cancel out, is 9x minus 38. And that should make sense, by the way, that you're saying the cube root of something equals the cube root of something else. So shouldn't that stuff be the same? I think that makes a lot of sense to me. Moving on from there, this is now just Algebra 1 land, where we can be happy and go about our day. Subtract 4 from both sides, subtract 9x from both sides. I'm just getting the variables to one side, getting the constants to the other side. We get negative 6x is equal to negative 42. Divide both sides by negative 6, and you get x equals 7. Or does it? Or does it? That's the question you got to ask yourself. X equals 7, or does it? So we can go ahead and check. When x is equal to 7, is it true that the cube root of 3 times 7 plus 4 is equal to the cube root of 9 times 7 minus 38. Is that true? Let's find out. 3 times 7 is 21 plus 4 is 25. So I get the cube root of 25 Is that equal to, let's see, this is going to be 9 times 7 is 63 minus 38. It is also the cube root of 25. Even though the cube root of 25 is a decimal, you could clearly say that the cube root of 25 is equal to itself. So we would say that's definitely true. And so this solution works out. Excellent. Hopefully no questions, comments, concerns about that. One more question I'd like to get through before our time concludes today is problem number 5 on that sheet. So going back to that little worksheet that I gave you, we got the square root of 2x plus 41 is equal to x plus 3. All right. Now, if you notice, a problem like this is going to be a little tricky because we have an x on the inside of that square root, and we also have an x on the outside of the square root. So that makes things a little difficult. I'd like to get rid of that square root. What I want to do first is isolate the radical. Lucky for us, that radical is already isolated. Like if there were a constant over here or like a variable stuck on this side somewhere, we would just want to get it out of the way, moving it to the other side. You can see that in something like problem number 6 on that sheet, where you notice the 3 starts out alongside the radical on the left. You just want to move that over to the right, get that radical all by itself. And once we have that, we can then go ahead and square both sides. The square and square root will cancel out. You get 2x plus 41 is equal to, now, again, this is what we talked about. This is where friendships can potentially fall apart. X plus 3 squared, remember, is not equal to x squared plus 9. It's a very easy mistake to make. It's a mistake that sometimes I make when I'm trying to do a problem really fast. I totally get it. I'm there with you. But remember, to square something, we want to make sure we multiply it by itself. And so that's going to be x plus 3 times x plus 3. Now just a little first, outer, inner, last. The distributive property on that right side, you get 2x plus 41 is equal to x squared plus outer is plus 3x, inner is plus 3x. So in total, that's plus 6x, and then plus 9. Now, if you notice, there should be a little like alarm or a signal that's going off in your head to be like, ooh, we got a factor because x squared just showed up. So whenever I see x squared show up, that's a great indication that I need to factor. And so in order to factor, we need to first set equal to 0. To accomplish that, we're going to subtract 2x from both sides. And we're going to subtract 41 from both sides. And you're going to get 0 is equal to x squared plus 4x minus 32. And now that's something we can go ahead and factor. Just a little quick refresher on factoring. I know I'm going to need x times x in order to make x squared. Since I'm multiplying to a negative number, I know I need different signs, one positive and one negative. And now I'm looking for some combination of numbers that multiplies to negative 32 and adds to 4. That's going to be positive 8 and negative 4. Because 8 times 4 makes 32, and 8 minus 4 is 4. That means we get two potential solutions here, one of x equals negative 8 and one of x equals positive 4. If you notice, I did say potential solutions because, just like before, we have to make sure we check for extraneous solutions. Okay? Hopefully no questions. Give you a little second to breathe that one in. But let's go ahead and check for our extraneous solutions. When x is equal to negative 8, just plugging right back into the top, is it true that 2 times negative 8 plus 41 is equal to negative 8 plus 3? Is that true? Let's see. Negative 16 plus 41, is that equal to, oh, sorry, the square root of it, my fault. The square root of 2 times negative 8 plus 41 is equal to negative 8 plus 3. Sorry, I forgot that little square root symbol right there. So is it true that the square root of, let's see, negative 16 plus 41 is equal to negative 5? That's going to be the square root of 25. Is that equal to negative 5? I don't like that. I don't like that. Ugh. No. No, 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 no. So that means that this solution right here is extraneous. And that might be a little bit of a sour note to start on, but there is still hope. And the hope is still for x equals 4. Is it true that when x is equal to 4, is it true that the square root of 2 times 4 plus 41, again, we're just plugging right back into the top, is that equal to 4 plus 3? I think that might check out. We got the square root of 49 is equal to 7. 7 is equal to itself, so we're happy with that. So this problem has one real solution and one extraneous solution. That real solution is x equals 4. That extraneous solution is x equals negative 8. All right. Any questions, comments, or concerns about that? I'll give you about 30 seconds just to digest that, and then I'll just talk about something else really fast, and we'll go from there. But hopefully no questions. Everybody's doing well. Everybody's paying attention. Everybody's focused. Everybody's tuned in to our first day of distance learning at Cumberland High School. How exciting. How exciting is that? You have to admit, it's a little cool. It's a little cool. It's a little cool. You might not want to say it because it's math, but I get it. It's a little cool. All right, any case. So just to go over the other two problems really fast, we don't have enough time to do them in full detail. Number 6 on that worksheet works out very similarly to the problem number 5. It looks like this. It's just 3 plus the square root of 5x minus 19 is equal to x. All you'd have to do at the very start is just isolate the radical by moving that 3 over to the other side, and you get 5x minus 19 is equal to x minus 3. The same process would apply here, where we distribute from both sides and then factor. And then just to talk about that last graphing example back on the other side, the last graphing example that I gave you looked a little complicated. It was 1/2 times the square root of 16x minus 48, all under the radical, and then minus 1. If you remember with a problem like that, we don't have to just dive right in. That's going to result in some messy calculations. Instead, you can go ahead and take a greatest common factor, take out a little GCF, turn that into 1/2 times the square root of 16 times x minus 3. Since you now have the square root of 16 times the square root of x minus 3, I know it's all the way at the bottom of the sheet, but hopefully you can still see that this would now be 1/2 times the square root of 16 times the square root of x minus 3. You can sort of, I forgot the little minus 1 at the end. You can sort of split apart that square root. And now the advantage of that is that the square root of 16 is equal to 4. So you get 1/2 times 4, which is 2 times the square root of x minus 3 minus 1. And we went from a problem that seemed hard and difficult and confusing to now a problem where you're like, oh, I can do that. No problem. Just create my chart, set up my goals, and go from there. So, all right. Hopefully we're all feeling good. Hopefully we're all feeling fantastic. That's all for me today. I am going to post another sheet to ask you guys to do for next time that is meant to be done in the time on Thursday morning, where you have that 2-hour block. So it's going to be just like this. There's going to be a couple other problems, maybe 4 problems this time instead of 6. Again, meant to be done in that 2-hour time window on Thursday morning. So if you could go ahead and give those a shot, that'd be fantastic. It's really just going to be a review of what I just did today. So you're going to see 2 problems like the graphs, 2 problems like the solving equations. What we're going to do next time is I'm going to show you a couple other equations to solve. In my opinion, I think that these equations towards the top, where you pretty much just have to square both sides and solve an Algebra 1 problem, that's what I'd label to be like a beginner level problem when it comes to solving equations. Something like this, where we have to square both sides and then do a little bit of distribution and factoring, that's what I'd consider to be an intermediate level problem when it comes to something like this. So Thursday, what I'd like to do is I'd like to show you a problem that I would consider to be more of an advanced level problem, a problem that requires a lot of distribution and a lot of stuff going on. You can definitely do it. I have full confidence in that, but I just want to make sure I show you that on Thursday so everybody's all clear. After we do that, I'll give you a little bit of practice. We'll probably go over it again next Monday. We'll explore some applications on Wednesday and Friday, and that should take us to the end of this at least initially projected 2-week virtual learning stretch. So if nobody else has any questions, we're ending just about 2 minutes early, so that's really all I have for you for now. But hopefully it was fantastic to, hopefully this made sense. What I'm saying from my perspective, it was fantastic to see everyone again, and it's something I really missed over this week of being indoors a lot and not really socializing with a lot of people because of social distancing. So it was really nice to be able to see everybody all grouped up again, and I hope you have a fantastic rest of your day. And again, if you have any questions, don't hesitate to reach out.